Welcome. In this module, we are going to compare the relational database and the NoSQL databases that we have looked at. All right, and we are going to dig deeper into some of the properties of RDBMS and the equivalent properties in the new age NoSQL databases. So here is what we are going to look at: the properties and applications of RDBMS, and what are the equivalent NoSQL properties and NoSQL applications, because for each of the different NoSQL databases that we have seen, there will be different set of applications. And then finally, we'll conclude by comparing relational database and NoSQL databases. Right? So let's get started. Let's try to understand some of the properties of relational database management system. In a RDBMS, a database transaction symbolizes a unit of logic or work, typically a change in the database. So, a transaction can sometimes refer to just one query, or a transaction can refer to multiple queries. Some of the examples are, if you want to just update a field with your new password, then it's one transaction, right? Whereas, let's say if you are creating a money transfer from one account to another, then it's going to be multiple queries that need to handle that, which means that we have to check for if there is amount in account A, debit account A, and then increment it in account B, right? So a transaction is essentially a basic unit of work. In an RDBMS system, transaction must follow what are called ACID properties to guarantee data validation despite power failures or network failures, etc. So what are these ACID properties? ACID stands for atomicity, consistency, isolation, and durability. So let's look at each of it. Atomicity. Atomicity is a transaction is the basic unit of work, right? It is indivisible. It either succeeds completely or fails completely. So this is very important to maintain so that the data is valid in a database. The next is consistency. So in a database, each transaction must transform the database from one consistent state to another. Right? So what is consistent state? To make sure that all of the constraints, everything are maintained in a database, right? So that's why the atomicity goes with consistency, because you can't have one transaction, incomplete transaction, partially executed transaction. It either has to execute completely, or if there was any failure in between, it has to roll back completely. The next is isolation. Isolation happens when there are concurrent transactions. So in a typical application, a large number of queries can come to the server at the same time, right? So each transaction executes independently so that the partial effects of each transaction is not visible for other transaction. So what happens in order to maintain isolation? A RDBMS system essentially serializes these concurrent transactions, right? So that the effect of one, so partial effect of one is not visible to other transaction. And finally, durability. Durability is committed transaction are persisted in the non-volatile memory, in the disk space, in case of a database crash, right? So if the transaction is committed, then the data is saved on the disk. So in a typical RDBMS, ACID properties are the golden rules for all of the transactions that's executed. All right. So one of the key things that differs from a relational database and a NoSQL database is a relational database scales vertically, which means the database spreads across multiple servers as they need a lot of space. They, of course, as we have seen, they have fixed schema and they manage only structured data. So they are centralized structure with high read scalability. So they are typically good for applications that needs to handle moderate volume of data coming in low velocity, right? So what are some of the applications for RDBMS? So we are all aware of a lot of these traditional applications, right? Banking. So the customer information needs to be stored, the account information needs to be stored, any of the loan information, banking transaction, all of it gets stored in an RDBMS system, right? And it's important to ensure data consistency, right? Very, very important for a banking system. So asset properties become very important. So banking tends to use the RDBMS system. Similarly, airline reservation as well. So if you are making a booking of a ticket, then your data consistency has to be maintained, right? So the reservation, cancellation, scheduling of the staff, right? All of it is maintained in an RDBMS system in an airline. Similarly, a lot of telecommunication systems also use RDBMS to keep track of network information, keeping tracks of records of calls made by your consumers, etc. So these are applications that we sort of see day in and day out, and RDBMS is very is the go-to database for these kind of applications, right? Where it needs to handle moderate volume of data coming in low velocity. So when we say low velocity, it's very relative, right? So even on the RDBMS space, there has been a lot of increase in terms of how much of velocity. So over the past decades, even RDBMS databases have increased capacity in terms of volume of data, relatively speaking, right? So most of these which needs transactional data and recording of transactional data, RDBMS system is the go-to database. So that is why we often talk about asset properties, right? Because for all of these applications, it is very important that the data stored is asset compliant, right? The atomicity, consistency, isolation, and durability is maintained. So what about the equivalent in NoSQL database, right? So in a NoSQL database, what are some of the properties? The NoSQL databases are not asset compliant. They provide base properties. So let's see what is base. So base stands for basically available, soft state, and eventual consistency. So what does basically available mean? So basic read and write are provided without any consistency guarantee, right? So especially when large volume of data is coming, so it's very important. NoSQL databases does not assure consistency, right? The second is soft state, which means the state of the system can be known when it's converged, but without any consistency guarantee, right? So when you have multiple transactions happening, so the system only eventually turns consistent. So for a fully functional system, you can get desired consistency only after waiting from a period. So not at every transaction level. So if you remember in an RDBMS property, we looked at the end of every transaction, right? The database is consistent. Whereas in NoSQL, for a fully functional system, it can get to eventual consistency is what is promised. So the base properties does not mean that the NoSQL databases are highly unreliable, right? In worst case scenario, they may not be able to guarantee asset compliance because it's depends on because they are catering to multiple data formats coming at very high velocity, etc. Right? On top of the base property, NoSQL databases are typically distributed databases. So they follow what is called a CAP theorem. CAP theorem states that in case of a network failure, any distributed data store can only provide two of the three guarantees. What are the three guarantees? That is what is the acronym CAP. Consistency, availability, and partition tolerance. Okay, so what is consistency? Consistency is that each read receives the most recent write or it should get an error, right? The second is availability. Every request receives a response, right? So here without the guarantee that it contains the most recent write. So you either have consistency or availability. Partition tolerance is in the event of a network outage, the system continues to offer despite messages being dropped between the nodes, right? So that is why NoSQL distributed data stores tend to have a lot of distributed computing properties, right? Replication, sharding, etc., in order to maintain this partition tolerance. So the trade-off is always between consistency and availability. Are we going to have the most consistent data, the most recent data, or should you have the ability to have your service available, right? So most often a distributed data store is usually CP, consistency partition tolerant, or available and partition tolerant, but it cannot be essentially both. Okay, so now let's quickly recap some of the features of NoSQL, right? So which we looked at. So NoSQL database is typically a distributed computing system. It's a distributed data store. Okay, so in a distributed data store, there are certain terminologies which are important to understand. One are the nodes, right? So in a distributed data network, so each networked computer in the data store that offers local storage and access to the larger distributed system is called a node, and a set of nodes is called a cluster. Okay, because the data is stored across multiple clusters. Then there is another terminology called sharding. Sharding essentially takes care of the partition tolerance, right? So it's called horizontal partitioning. So partitioning, so how do we partition data across these multiple clusters? Partitioning database based on value of some field, right? So there is a key that is used in order to partition your data across multiple data clusters. Another thing in order to make sure the distributed data store is replication, right? So multiple copies of the data is maintained. So portions of data are written to multiple nodes in case of failure to ensure availability, right? So one of the very important mind shift that we have to start looking at is the NoSQL databases is basically a distributed data store and built for the high velocity and high variety of the modern web application. So other than this, of course, there is high scalability, right? This is what we have seen. And then reduced cost of your, because the idea is for a relational database system, typically it needs to work on sophisticated hardware, whereas a NoSQL database can work on any simple hardware systems as well, because there are multiple clusters that can come together to provide the service itself. So reduce cost in terms of hardware, flexible schema design that we have already seen, the ability to process unstructured and semi-structured data, right? And then no complex relationship, and most often all of the NoSQL databases are open source. Having seen some of the properties of NoSQL databases, right? The base properties and how NoSQL database follows the CAP theorem, let's look at some of the applications of NoSQL database. So we'll look at applications one database at a time. First, let's look at key value store. So quick refresher, key value store is where the data model is simple as key and value, right? So what are some typical applications? Applications which need quick CRUD operations on non-interconnected data is typically applications for key value. So some examples are shopping cart data for online stores, right? So as let's say there might be shopping carts which can have up to 10 or 15 different items, etc. So all of these needs to be stored in a data store, typically a key value store. So the in-app user profile and preferences that the user refers to, right, has saved, all of that can be in a represent in a key value. So one of the greatest advantage, as we seen earlier, is a key value store accesses data very fast because it's indexed based on key. So next is your columnar database, where instead of storing data as rows, these database store data based by creating column families. So they are great for large amount of sparse data, right? Because as we saw earlier in an example, columnar stores tend to do a lot of data compression, right? So they are great for storing large amount of data, especially sparse data. So what is sparse data? Sparse data is one in which you have a lot of columns, but not all the rows have values for all the columns, right? So there are a lot of null values where there is no data for it, right? So those are essentially sparse data. So columnar database is great for storing sparse data because of its data compression, this thing. So some of these column database have unique use cases called counters, right? So your Cassandra database, counters are unique use cases for column database because they are mostly used for analytical workload in order to do aggregation, as we have seen, right? Your sum, your average, etc. And they are typically used for data warehouse and big data processing systems, all of these columnar database. Next, we look at graph database. Graph database has been used for a number of different applications. So one of the very popular application is fraud detection, right? So in a relational database, it's very difficult to look at how many hops from a particular entity, is another entity, the interconnection between the different entities, because each entity is represented as a row in a table, right? So in one of the applications that we built earlier, we got some information about blacklist entities, right, from a third party vendor. But we also wanted to create these gray list risk entities based on the blacklist, right? Because fraud may not originate always from the blacklist entities. So there could be other entities around it which might be the source of fraud, right? So it helps us to create these different shades of gray entities. Of course, another application is personalization and recommendation. Then you have knowledge graph, right? So knowledge graph is also very increasingly being used in enterprises to create and store the knowledge within an organization and to find dig new age inferences from the existing knowledge, some sort of connections that may not have been apparent, but to look at these inferences through knowledge graph. And of course, network operation mapping. So then you have your document database. Document database, because it is essentially schemaless and can stores data in terms of documents, it is used a lot to store online user profile information, right? So each profile can have different set of attributes. So there could be a profile which is connected to Facebook, probably Twitter. So if you have those handles, whereas some profiles are probably not, you don't have the equivalent connections in them, right? Or you don't have you may not have the personalization information for some of the profiles, right? Then of course your product data management and product catalog, right? So different products might have different attributes to it. So you want to create a document database for it. Next is you can do real-time data integration, especially when your data is unstructured format, right? So when your data is having multiple variety and coming, you can just dump them as documents into a document database. So some of the popular applications that use document database, especially MongoDB, is your Aadhaar card application, right? Uses MongoDB. Then you have the Shutterfly application, which is a photo organization app, photo organizing app, which also use MongoDB. So now let's look at the comparison of relational database and NoSQL databases. And we'll do it based on each feature, right? So when you talk about scaling, a relational database is vertically scaled, right? So the architecture design essentially runs well on a single machine. So to handle larger volume of operation, machine needs to be upgraded with faster processor or memory. Whereas your NoSQL databases is horizontally scaled. So they are intended to run on clusters of comparatively low specification server. So to handle more data, more server are added to the cluster, right? So this is one of the reasons. So your NoSQL database are typically lower in cost because they are intended to run on clusters with low specification hardware requirements. Whereas for an RDBMS, you typically need sophisticated hardware. So maintenance, from the maintenance perspective, maintaining high-end RDBMS system is expensive. It requires workforce that is trained in database management, whereas NoSQL databases typically require minimal management. They support many features that make the need for administration less and less. Then you have the what kind of data model can be stored in relational database. Relational database tends to have rigid data model, structured format with defined data model. So what happens because of that is the change management is a challenge in SQL with strong dependency on primary, foreign key, etc. Right? So if you are just going to add a particular attribute, etc., so you have to make sure that the consistency factors of your database is maintained. Whereas in a NoSQL database, there is a lot of flexibility. So it's a no schema data model. Data can be inserted into a database with ease without any predefined schema, right? So you're not defining a physical data model and then coming on to looking at your application, right? You can actually insert your database without any schema. Format or data model can change without application disruption. Whereas in an RDBMS application, you need to go ahead and change the data schema so that the application makes the corresponding change. So the development cycle tends to get longer in an RDBMS based system, unlike a NoSQL database system. Caching is typically required. If caching is required, it's separate infrastructure for a RDBMS system, whereas caching is supported in memory, in system memory, which increases data output performance for the NoSQL database. So we can sort of see in what cases what are the key differences between your relational and non-relational database. So now let's talk a little bit about database as a service, right? So database as a service is a cloud computing service where everything connected to a database is handled by the service provider. One of the key things that we saw about relational database, right, is the administration part of it. So time-consuming infrastructure administration is offloaded to the service provider, and they are responsible for ensuring the physical and application layers are operational and optimized. So let's take a look at this diagram, right? So what happens in an on-prem database which you are managing on your own, you have to take care of multiple things: the networking, the storage, the servers, virtualization, the operating system, middleware, runtime. All of these admin has to be taken care in order to load it with data and build application on top of it. Whereas in a database as a service, the service provider tends to sort of take care of all of these parts, right? So the time consuming administration bit is removed from it, and organization can focus only on the data and application. There are multiple database hosting options that are available for relational database and NoSQL database. So relational database like Postgres, MySQL tends to have database as a service as well. NoSQL database like MongoDB Atlas, your Amazon Document DB, etc. also are the database as a service. So some of the advantages of database as a service is rapid database deployment, right? Future ready data operations, and no additional on-site hardware. So the on-prem, there is no need for a database admin to take care of on-premise database, and there is no requirement for on-site hardware at all. In this slide, we are going to take an application example to see how would it be if the application is implemented as an RDBMS and if it is a NoSQL document DB. Right, so this is an application we are all familiar with, the LinkedIn application. So on the left, we see the LinkedIn profile of Bill Gates, right? Using the how will the data model look like in a relational schema. So there are multiple entities: the user, the region, the industry, position table, education table, the contact information. So why are there so many tables? Because we always believe in normalization of our data, right? Instead of putting it all in one table, just as a user table, it's important to make sure, because there is one-to-many relationship that can happen, many-to-many relationship that can happen in a relational database. But if you look at the equivalent in from a document perspective, so you see it is a very simple JSON file, right? So you have the attributes and the corresponding values for each of it, and then for multiple values you tend to have an array of values for position or the contact information, etc. So there are a bunch of different values, right? So I would like you to start noticing about this part, the region ID, right? So here region ID, we are specifying a code and not the text, and industry ID is also a code, it's not a text. So this corresponds to probably the greater Seattle area, right? And the industry ID is probably philanthropy, as we see here. So why is that it's important to give a code? Because it becomes easier in terms of consistent style and spelling across the profile, right? Instead of giving open text field for them to enter the region or the industry, we are giving them essentially a drop down, right? That's essentially what this means. So we are avoiding ambiguity if there are several cities with the same name, etc. So we know which city is being referred to. Ease of updating, because the name is stored in only one place, so it's easy to update across the board if there is a need for change, right? And of course, if you want to implement higher levels of features such as localization support, right? When the site is translated to other language, then the standardized list can be localized. So the region and industry can be displayed in the viewer's language. And of course, because of the region ID and industry, we can also get better at search so if you are searching for philanthropists in the state of Washington, it can match this profile, because the list of regions can encode the fact that Seattle is in Washington, right? So whether you are storing an ID or a text string is a question of duplication. So when you use an ID, the information that is meaningful to the human is stored in only one place, and everything that refers to uses an ID, right? When you store the text directly, you're duplicating that text, like philanthropy, at multiple places. So you're duplicating the human meaningful information in every record that uses it. Now let's look at some of the challenges that are brought about by creating your data model in the NoSQL database. One of the key things is in RDBMS, joins are supported inherently, but a lot of NoSQL document database do not support joins, right? So if joins are not supported, then the only way to emulate a join, right, is by in the application code, not in the database side, but on the application code, by making multiple queries to the database, right? So in the case of the region ID and the industry, right, we are assuming these are very small in number and they don't change very often, right? So they can be stored as just as a tuple in the application code, so that it can be represented as a drop down for the user to select. However, it is very important to note that the work of making these joins, right, is shifted from the database to the application code. So sometimes, even if the original application, let's say your LinkedIn fits well in the document model, but sometimes as the features, more features are developed in the application, the data tends to get interconnected, resulting in many-to-many relationship. So let's take an example. So one example is the organization and the school name. Currently it's a text information, right? But from text information, let's say it is becoming entities. So you are creating entities. So each organization have a bunch of number of people working on it. So you see that clickable thing, right? On if you go to Microsoft, then you can click and go to a LinkedIn page of Microsoft itself, or the LinkedIn page of your particular school itself, right? So in that case, then you have to, so your entity will have a different document format, right? So you will have to store that document format and occasionally need to join it with the user document format as well. So another example is recommendation feature. So let's say you want to, so in a recommendation feature, if your recommender needs to, so in a user profile, all of the recommenders photo also needs to come, right? So along with the user profile, you need to store the some of the information about the recommender as well, right? So that if you need to create some sort of a nice report where the recommender's photo comes up and also the story, so that in case the recommender changes their profile photo, right, then your report will also get the updated ID. So it's very important to see that as the application changes, right, so the needs of the database might also change. So although you initially there wasn't a requirement for joins, eventually joins might be required. So you will see both kind of changes happening. So a lot of properties of NoSQL, like the schema-less information like JSON, XML format, has been adopted into the RDBMS as data types, right? Similarly, some of these joins, etc., of the relational database will also get adapted into NoSQL databases eventually as we start making more complex applications. So as the application needs increases, both sides, so as you see, NoSQL databases are evolving these days, right? So they will also start making these features available eventually. So how do we choose a database, right? So that is something we've talked about, a bunch of different databases: relational database, your NoSQL database, and within the NoSQL database, 4 different types of it, right? So different NoSQL database is meant for different use, right? The choice of database will depend on the database features, how queryable it is, what is the data model in which you can store, is your application be able to store it in the data model, right? Performance, so what about the consistency, availability of the database, etc. And the context based criteria, for what application are we using a database, right? So how do you, the database of choice should be close to the application which needs to be done using the data, right? So in most organization, it is never, as we started off in the discussion, it is never relational versus NoSQL. However, it's relational plus NoSQL for specific application. So you can have different application servers. So for example, in an e-commerce application, you can have the session data, shopping cart information in a key value store. You can have the product catalog, the user accounts, the domain object in MongoDB, which is your document DB. You can have the payment information, reporting information in RDBMS. Any of the social media, social data recommendation can be a graph, right? So this is what we call polyglot persistence, right? So the knowledge and use of multiple database products and methodology. So mostly one of it is definitely RDBMS. So we see how NoSQL can add on to other specific application in addition to your RDBMS. Let's summarize what we have learned in this module. So we looked at some of the properties like the asset property of RDBMS, which is very important, and some of the applications of RDBMS in a lot of these traditional applications that we have used to, right? Then we looked at NoSQL properties, the base properties, and then the cap theorem, right? So things that you need to remember while working with NoSQL databases. So we also looked at some of the application of NoSQL databases, right? And then we compared relational database with NoSQL database and took an example to understand some of the challenges that exist and how some of the properties tend to go across from relational database properties are being today adapted into NoSQL databases, and NoSQL database properties are some of those features are being adopted by the relational database tables. All right. So I hope you enjoyed this session. I will see you in the next one. Thank you.